In this video, we will talk about how to determine if a sequence is arithmetic or geometric. So there's two rules of thumb we can use to determine if a sequence is arithmetic or geometric. We say that a sequence is arithmetic if the term a2 minus a1 is equal to the term a3 minus a2. And we say that a sequence is geometric if the term a2 divided by a1 is equal to a3 divided by a2. So let's work through a couple examples of how to actually use these formulas in practice. So let's say we have the sequence 2, 4, 8, 16. How can we determine if this sequence is arithmetic or geometric? Well, first let's go ahead and label these values. So 2, we'll say that's a1. 4, this is the term a2. 8, this is the term a3. And we'll say 16 is a4, the fourth term in the sequence. Let's go ahead and check if this is an arithmetic sequence by using this formula, a2 minus a1. So a2 is 4 and a1 is 2. So we'll say 4 minus 2. We'll check if that's equal to a3 minus a2. So a3 is 8 and a2 is 4. So 8 minus 4. So on the left-hand side, we get 4 minus 2, that's 2. On the right-hand side, we get 8 minus 4, that's 4. So these are not equal. So this is not an arithmetic sequence. So now let's check if it's a geometric sequence. So we can use the formula a2 divided by a1. So a2 is 4 and a1 is 2. So is 4 divided by 2 equal to a3 divided by a2? So a3 is 8 and a2 is 4. So on the left-hand side we get 4 divided by 2, that's 2. And on the right-hand side we get 8 divided by 4, that's also 2. So that checks out. So this is a geometric sequence. And one cool thing about this is that when we use this method, this value that we find, this 2, this is actually the value that we can multiply any term in the sequence to get the next term. So if we have a 2, if we multiply that by 2, we get the next term in the sequence, which is 4. Similarly, if we have 4 and we multiply that by 2, we get the next term of 8. If we have 8, we multiply that by 2, we get the next term of 16. So that's kind of just a cool way to double check ourselves to verify that this is indeed a geometric sequence, which means we're either multiplying or we're dividing by some number to get the next term in the sequence. All right, let's try another example. Let's say we have the sequence 5, 10, 15, 20. How can we check if this is arithmetic or geometric? Well, first we'll check if it's arithmetic by doing a2 minus a1, and we'll see if that's equal to a3 minus a2. So let's go ahead and label these. This will be term a1, this is a2, a3, and a4. So a2 minus a1, that's 10 minus 5. So 10 minus 5. We'll check if that's equal to a3 minus a2. So a3 is 15, a2 is 10. So 15 minus 10. So on the left-hand side, we get 10 minus 5, that's 5. On the right-hand side, we get 15 minus 10, that's also 5. So these two values are equal, so we'll say yes, this is arithmetic. And once again, a cool trick that we can use is if we want to verify that this is arithmetic, what we're saying is we should be able to add this value of 5 to each term in the series to get the next term. So if we do 5 plus 5, we do get the next value of 10. If we do 10 plus 5, we get the next value of 15. And if we do 15 plus 5, we get the next value of 20. So that's another way to double check ourselves. Okay, let's try another example. Let's say we have 120, 60, 30, and 15. How can we determine if this series is arithmetic or geometric? Well, first, let's go ahead and label each of these values. So this will be a1, this is term a2, this is our term a3, and this is a4. Let's first check if this is an arithmetic series. So a2 minus a1, so that would be 60 minus 120. Let's check if that's equal to a3 minus a2. So a3 is 30, a2 is 60. So on the left-hand side, we get 60 minus 120, that's negative 60. And on the right-hand side, we get 30 minus 60, that's negative 30. These values are not equal, so this must not be an arithmetic sequence. So next, let's check if it's geometric. So a2 divided by a1, so 60 divided by 120. Let's check if that's equal to a3 divided by a2. So 30 divided by 60. Well, 60 divided by 120, that can be reduced to 1/2. And 30 divided by 60, that can also be reduced to 1/2. So this is a geometric sequence. And once again, we can double check that this is correct by using this value, 1/2 that we just found, and saying if we multiply any term in the sequence by 1/2, do we get the next value? So if we do 120 times 1/2, do we get 60? Yeah, we do. And if we do 60 times 1/2, do we get 30? Yep. And the last one, 30 times 1/2, we get 15. So that's just a way to double check ourselves. Okay, let's try one last example. Let's say we have the series 18, 15, 12, and 9. Let's determine if this is arithmetic or geometric. So let's first label each of these values. So this will be term A1, this is A2, A3, and A4. So let's first check if it's arithmetic. So A2 minus A1, so that's 15 minus 18. Is that equal to A3 minus A2? So A3 is 12, minus A2, that's 15. So on the left-hand side, we get 15 minus 18, that's -3. On the right-hand side, we get 12 minus 15, that's also -3. So yes, this is an arithmetic series. And once again, we can double check ourselves and say, well, this value that we just found, -3, can we add that to any term in the sequence to get the next term? So if we do 18 minus 3, do we get 15? Yes. If we do 15 minus 3, we get 12. And if we do 12 minus 3, we get 9. So that's just a way to double check ourselves and verify that this is indeed an arithmetic sequence.